This video reviews how to solve simultaneous equations with inverse matrices. Now it's a review only. I'm not going to go into a lot of detail. It's just to revise what we've done. Now if we've got a system of linear equations, ax plus by equals u, cx plus dy equals v, we pull out the coefficients to make our coefficient matrix. So a, b, c, d, and that coefficient matrix is A. Our variables are x and y. So that's our variable matrix, x, and then our constants are u and v. That's matrix B. So we have ax equals b. To get what we're trying to do is get x on its own. So we pre-multiply by the inverse of a. If we do that on one side, we have to do it on the other. Make sure we're pre-multiplying. Now, the inverse of a times by a, you'll remember, is our identity matrix, and anything times by our identity matrix is itself, so that leaves us with x on the left hand side. So x equals the inverse of a times by b. Now this is all assuming that the inverse of a exists. If it doesn't, then we have no solution. And that's going to be really important in this topic when we're talking about what are the possibilities of solving equations. Now also remember that the inverse of A is 1 over the determinant of A times by D negative B negative C A, and the determinant of A is AD minus BC. Now all of this is on your formula sheet. So make sure you know where that is located. Now, provided we can find an inverse for matrix A, we can solve the equation for x. Additionally, if ax equals b, then we have x is a to the negative 1b, or the inverse of a times b. If xa equals b, because we're going to have to post multiply, x is b times the inverse of a. So let's look at an example. Solve the following simultaneous equations using inverse matrices. So we're told what method to use. So let's set up our matrices. Firstly, our coefficient matrix, looking at the coefficients of our equations. Now remember that there is a 1 there and there is a 1 there, and always take the sign in front. So A is 1, 2, 3, negative 1. Our variable matrix is x and y, and matrix B, our constant matrix, is 4 and 5. Now write down what we're doing. We've got ax equals b. We pre-multiply inverse of a times a of x equals the inverse of a times by b. That gives us ix on the left-hand side is the inverse of a times by b. So x is the inverse of a times by b. Now we can work out what that is. So x equals the inverse of a times by b. So that's going to be 1, 2, 3, negative 1 to the power of negative 1 times by 4, 5. Now you could go straight to your calculator in a tech active exam. If it's not a tech active exam, we need to work it out by hand. So the determinant of A is the first thing we do to make sure it has an inverse. So 1 times by negative 1 minus 2 times by 3. So that's negative 1 take 6, which is negative 7. So the inverse of A is negative 1 over 7 times by negative 1, negative 2, negative 3, 1. So come back, we have negative 1 over 7, negative 1, negative 2, negative 3, 1 times by 4, 5. Now, if you are doing this by hand, do this first. Okay, worry about the negative 1 over 7 last. Now, I am going to do this by hand. So across the row down the column, -1 times by 4, minus 2 times by 5, and then -3 times by 4, plus 1 times by 5. So that gives us -1 over 7. -1 times by 4 is -4. -4 take 10 is -14. -3 times 4 is -12. -12 plus 5 is -7. So that gives us -1 over 7 times by -14 is 2. -1 over 7 times -7 is 1. So always remember to multiply by that scalar last. Leave that -1 over 7 till the end. State your solution. Therefore, solution is x equals 2, y equals 1. Now you can also check your solution by substituting back into your original equations. So x is 2, 2 plus 2 times 1 is 2, 2 plus 2 is 4, that works. 3 times 2 is 6, 6 minus 1 is 5. So we know it's correct. Our next example is with 3 variables, so solve the following simultaneous equations. Again, it says using inverse matrices. So construct our matrices. Our coefficient matrix is looking at the coefficients. And remembering that there are ones. So A is 2, 1, -1, 1, -2, 3, 3, 5, -1. Our variable matrix is X, Y, Z. And our constant matrix is our 2, 7, 0. Write out what we're doing. AX equals B. We're going to need to pre-multiply. Inverse of A times X equals the inverse of A times by B. IX equals the inverse of A times by B. So X equals the inverse of A times by B. Now let's work that out. X is the inverse of A times by B. So that's going to be 2, 1, -1, 1, -2, 3, 3, 5, -1 to the -1 times by our B, 2, 7, 0. Now there are 3 variables, so we can use our calculator to work this out. So using your graphics calculator, and we get 2, -1, 1. So therefore, solution is x equals 2, y equals -1, and z equals 1. Now check your answer. It is very easy, even when you're using a calculator, to forget to put the inverse to the -1, for example. Okay, so always check. So go back to your original equations, go 2 times 2 is 4. 4 minus 1 is 3. 3 minus 1 is 2. So yes, that's worked. And just work your way across.